Good afternoon, everybody, and welcome to Agri-Food Conversations, brought to you by iSelect Fund, the Van Frump Report, the Yield Lab Institute, and Family Farms Group. My name is Tom Bunn, an associate on the iSelect Fund Ventures team, and I'm excited to welcome you all to our discussion today. Agri-Food Conversations is all about driving innovation in food and ag. Each month, we highlight a specific theme, and for the month of November, we are highlighting companies working in the sugar reduction space. On today's call, we are joined by Ed Rogers, the CEO of Bonumose, which is making rare, healthy, and functional sugars at low cost. Each of you knows companies are more likely to succeed with the right network of customers, talent, investors, and advisors. We've invited you to this call because you are some of the smartest, most talented people in Bonumose. You are potential customers for Bonumose's products. You built a company similar to Bonumose, or you are a sophisticated business person or food and ag professional who understands Bonumose's market and the challenges and opportunities that they may face. Before we get started, we have a quick poll question to get a better idea of who we have on the call today. Please take a few moments to answer. While you're answering the poll question, a few process comments. We are not soliciting investment. This presentation is to provide information to help Bonumose find customers, mentors, or other strategic relationships that can help them grow their business. Secondly, you are all on mute. However, you can use the chat window to ask a question at any time. And at the end of the presentation, we will have a dedicated Q&A portion of the call during which you can type in a question in the question pane and I can read it aloud, or you can raise your hand and ask Ed the question directly. Finally, this presentation is being recorded and will be available for replay. So without further delay, I'm pleased to introduce Ed Rogers, the CEO of Bonumose.
Thank you, Tom. Appreciate the opportunity to talk to you and your audience. So at Bonumose, we have a way to make healthy sugar affordable for the mass market, and I'll tell you a little bit about that. In today's presentation, we'll cover how tagatose and allulose can be used in food production, how tagatose and allulose are produced, both from us, but also from the other methods of producing it that we believe we will replace, a little bit about our business model, a recent regulatory development, and then some time for Q&A. So before discussing tagatose and allulose and our method for making them, it's important to give a nod to sugar. So sugar is the gold standard of sweeteners. It tastes great. It makes food taste great. It's also very functional in food, and this is something that's often overlooked when it comes to sugar replacement, because sugar provides bulk to foods, it provides the body to food, it does a lot of things in foods besides provide sweetness, or in addition to providing sweetness. Then it's really, really cheap. So no matter how healthy a sweetener is, it's always going to be judged against these features that regular sugar has. We think tagatose and allulose stack up really, really well. So first on the health side, these are naturally occurring sweeteners. They occur in nature in very, very small quantities, in some fruits and some vegetables and grains, but too small to be able to harvest. So they can be made from other things, as I'll describe. They're very healthy sweeteners. They are good for metabolic health in terms of being low glycemic. They will not increase blood sugar levels. They actually have the effect of reducing blood sugar levels, particularly when consumed with a high sugar or a high starch meal. If you eat tagatose and allulose, that has an attenuating effect. They're also low calorie. They're safe for teeth. Tagatose even breaks up dental biofilm and can be used in toothpaste and mouthwash. And they're good for, at least tagatose is good for gut health. It's a prebiotic fiber that in the large intestine feeds the good gut microbes and leads to good gut health, which of course is associated with many, many positive health outcomes, including immunity. So what we like to say is these are beyond benign. These are not just not bad for you. They're actually sweeteners that have positive health benefits, beneficial effects on human health. But you don't sacrifice with these health properties. They are very, very close analogs to regular sugar, not exactly drop-in replacements. But compared to other sugar alternatives, they have many advantages. They taste really close to regular sugar. 92% as sweet as regular sugar in the taste of tagatose. They provide the functional advantages that regular sugar does in terms of bulking, baking, creaminess in ice cream, and many other attributes of regular sugar. And they also have some labeling advantages that I'll describe later on in the presentation. So the problem has been traditionally the cost, and this is what we are solving for. The cost is the high cost of rare sugars, tagatose and allulose, is driven by some inefficient production methods. The typical way of making tagatose is to take lactose, which from dairy, to split it into its components, galactose and glucose. Then you have to separate those, and the galactose can be converted to tagatose with an enzyme. But it's a reversible enzymatic reaction, as most enzymatic reactions are, and it favors galactose over tagatose. And so what results is a pretty low yield, and if you trace it back to the lactose, a very low yield of about 20% or less, and some complicated processing steps. But our breakthrough is to start with starch, a commodity starch that's available globally and quite abundant, and we can convert it in a single pass to about 85% yields of tagatose. This is through linking together enzymes to create an irreversible enzymatic reaction. It only goes one way. The same thing applies to allulose. Now, there are companies such as some of the corn refiners, Tate & Lyle Ingredients, Ingredion, and some others that produce allulose from fructose. And to get that fructose, they have to convert glucose to the fructose. So this method works. The steps involve taking starch, converting that to glucose, and then there's a purification step, and then an enzyme that converts glucose to fructose, but that's a reversible reaction. It's about 45% fructose. Then you purify out the fructose, and there's an enzyme that will convert fructose to allulose, at best a 30% conversion. Again, it's a reversible enzymatic reaction. So overall yields are very low. Now this method works, but it's the old way. It's old thinking. It's a little bit like using a dial-up modem to get on the internet. I'd prefer fiber optic cable. So Bonumose's process is to convert starch to allulose, very similar to our tagatose process. It's an irreversible enzymatic reaction, a single pass. We don't have to go through all these intermediate steps, and we get extremely high yields. And these high yields and elimination of processing steps results in lower cost. And I'll talk a little bit more about that in a minute. So there are three breakthroughs that are driving our low cost. First, we're doing this with irreversible enzymatic reactions. So unlike the old way where you have a reversible enzymatic reaction, ours are irreversible. They are not going to go the other way. Secondly, we use globally abundant low-cost feedstock, starch. And then we can do this in a continuous process using immobilized enzymes and, frankly, standard high fructose corn syrup production equipment with some crystallization equipment on the end. Now, these breakthroughs are globally protected through patents and multiple patent applications all over the world. The interesting thing about our method is that there's a sustainability story here too. We can repurpose dormant high fructose corn syrup production assets. If you go back and you look at the peak of high fructose corn syrup in the United States, about 15 or so years ago, it peaked. And ever since then, it has been declining, and about 2.5 million metric tons of production have come offline over the past 15 years. And so that's a lot of production that's coming offline, and these assets can be repurposed and used with our enzymes to produce healthy sugars instead of high fructose corn syrup. Another interesting thing is that we can use waste starch. And so, for example, when French fries are cut, there's some byproduct starch that's left over. That starch is perfectly suitable to use in our process, and we have used it. And we recently entered into a transaction involving a waste starch source that's very interesting that we'll be announcing probably early next year. We also can use the starch that is a byproduct of, for example, pea protein production. So plant-based protein has starch that is a byproduct. For every unit of protein from peas, you have 2 units of starch at least. And so this is a way that we can upcycle this waste starch get it at low cost, non-GMO source, and produce healthy sugars. There will be a small amount of side stream simple sugars from our process, very, very low amount since our yields are so high. But this small amount of byproducts, glucose, maltose, and things like that, we also can capture and utilize. A little bit about our business model. So our primary focus is B2B. So we are talking about producing tagatose and allulose for distribution to food and beverage manufacturers. This is an enormous market, over $100 million a year in sugars and sweeteners. Our plan is to control production. That doesn't necessarily mean that we will do all the production. In fact, I'm sure that we will not do all the production, but we intend to control it. And that means the production of the ingredients as well as the production of the enzymes. And then when we go to market, we will be going to market through distribution partners such as the ASR group. I'll talk a little bit about them in a minute. We also have a B2C strategy for selling tagatose in grocery stores and at cafes. It's a very large market. In the US alone, it's $500 million for sugar alternatives. And then we have a series of new ingredients and new industries that we can attack. One of the interesting ones is crop protection. We've been approached by a company that is developing a biofungicide that has tagatose as an active ingredient, and it protects against a potato pathogen. So our first distribution partner, we're very pleased, is the Domino's Sugar Company. They go by ASR Group also. They have deep customer relationships and food applications expertise. It covers North America right now. We work with them on a pilot plant in which we produce a ton of tagatose, which is being sampled out to customers now. And we're also talking to distribution partners in other countries. So quick on retail, just to show you what this could look like. All of the sugar alternatives that are on the market today are very expensive. They're not necessarily all that great tasting, but they're not necessarily all that functional in foods, but one thing they do have in common is that they are expensive compared to regular sugar. And we can be down there in the range of organic cane sugar. So we'll have an affordable offering for consumers as well. So the regulatory development that I touched on earlier is that allulose has been exempted from the definition of sugar. So the USDA currently defines sugar for purposes of grams on the nutrition facts label as being all monosaccharides and disaccharides. Allulose is a monosaccharide, but because it does not increase blood glucose or insulin, because it's low calorie, and because it's safe for teeth, the FDA has exempted allulose. And just a couple of weeks ago, they made that exemption final. And they also sent out a request for information about other sugars and indicated therein that they recognize tagatose as a healthy sugar. Tagatose certainly meets the same criteria that allulose was judged on. So we believe tagatose will be exempted. Don't want to put up the bats before the game is over, but do believe that tagatose will be exempted from sugar. And there's even the possibility that it'll be classified on the nutrition facts label as fiber. So we have a strong team. It's a small team, but we've been able to leverage the talents of our commercial partners. And my co-founder was Dan Wichelecki, who is our chief scientific officer. He was also the inventor of almost all of our patented and patent pending technology. He was certainly a co-inventor on all of it. And we have a very strong team that backs up Dan as well as some external partners. So wrapping up now, what Bonumose can do is we can make healthy sugar. We can do so in a way that is affordable for the mass market. And so this is an enabling technology that allows for our customers and consumers to make healthy food without having to sacrifice taste or texture or their pocketbook. And we believe that this will have a positive impact upon health and wealth, and look forward to answering your questions. Tom, over to you.
Great, Ed. Thanks so much. As a reminder to the attendees, to ask a question, you can type a question into the Q&A box or raise your hand, and I will unmute you to ask a question out loud. And I guess to get things started, how would you kind of segment the main competitors here? I know there's kind of bitter blockers, high intensity sweeteners. Do you think there's
Yeah.
room enough for kind of all segments, or who do you think you're going up most directly head to head with?
Yeah, so there are going to be a lot of winners when it comes to sugar reduction, and sugar is also not going to go away. Um, so there's a lot of ways to replace the sweetness if you take out sugar, but with bitter blockers and some of the high intensity sweeteners, we think those are good solutions. But what they don't do is they don't offer the bulking properties that sugar has. And so when you take out sugar, you have to make up the bulk somehow. Um, and then high intensity sweeteners have been gotten some knocks for being not so great tasting. They also have an unusual onset of sweetness and a sweetness lingering, and so tagatose and allulose blend really well with them. We think the ones that are probably the closest in competition to tagatose and allulose are polyols, also known as sugar alcohols. So you're talking about maltitol, used a lot in chocolate, and chocolate's a fantastic application for tagatose. Erythritol, xylitol, and many of the other polyols that have really low gastric tolerance, much lower than what you would see with tagatose or allulose. And also, oftentimes you have undesirable properties such as the inability to bake with them or to caramelize, or think hard ice cream. That's a polyol that's creating that hard ice cream in some of those brands. So we think we'll take market share from polyols. We think we'll take a market share from high fructose corn syrup, a little bit from sugar, but then also we will be a complementary sweetener with high intensity sweeteners.
Got it. Thank you, Ed. We have a question from Craig R. They ask, what are your market share projections?
Well, it depends on if you mean market share of allulose and tagatose or market share of sugar. With market share of allulose and tagatose, I'll be so bold as to say we'll be 99% of the market share. And that 1% maybe just hadn't heard about us. On sugar, I think that we have the opportunity to sell at least 1 million metric tons a year within the next several years. And that is only about 0.5% of global sugar volume, somewhere in there. And so that's an enormous opportunity for us. I mean, it's a multi-billion-dollar a year opportunity for us, but it's still just scratching the surface. In comparison, high fructose corn syrup is around 10% of global sweetener volume. And so, if we were to get anywhere near that, then that would be a very good thing.
Great. An anonymous attendee asks, would you replace 1-for-1 with sugar in baked goods? And does it brown, caramelize in the same way?
So it does brown and caramelize, not necessarily in the same way. Tagatose actually browns at a lower temperature and lower time than sucrose. And that could actually be a good thing. One, it may be more desirable for consumers, but two, it might mean that bakeries could use less energy for the same product. Not exactly a 1-to-1 replacement. So allulose is 70% as sweet. And so the replacement would be 1.4-to-1 if you want to achieve the exact same sweetness, substituting allulose for sucrose. With tagatose, it's 92% as sweet, so it's more of a 1.1-to-1. And I will caution that even though they're very, very close to drop-in replacements and very, very close analogs, it's not exactly the same. So there are some, formulations that need to be experimented with to get the right usage level.
Great. I guess a follow-up to that question, Ed, is when you say things like 70% is sweet, does that bear out in the consumer panels that have been done on tagatose and allulose?
Yeah, so that's where that's coming from.
Okay.
They're perceived to be that sweet, but it's going to vary from person to person. But on average, allulose is perceived to be 70% as sweet. tagatose is perceived to be 92% as sweet. And actually, one of the interesting things about tagatose, it has been shown that the sweetness level is consistent across all concentrations, whereas with high intensity sweeteners, there's actually an upper limit. I mean, the more you put in, you're not going to get the same, you're not going to get that much more sweetness out of it. And then I think it's with erythritol, the sweetness varies from like 60% to 80%, depending upon the concentration of the erythritol in the formula. So tagatose tends to be like sucrose in terms of being consistent in across all concentrations.
Got it. Thank you. Tom Gable asks, please expand on how you optimize your enzyme portfolio for mass production of tagatose while replicating both quality and taste and quantity and stabilization.
Okay, so that's I have to unpack the question. We have a good supply chain for the enzymes themselves. If the question is related to the enzymes, we have a good supply chain for the enzymes, and actually have some interesting ideas about how we can develop in-house enzyme expertise and not have to be relying upon third parties. In terms of quality control, I mean, that's something that's always going to be important to us. I can say that the purity of the tagatose that we've made so far is 99.6% pure, which is higher than the tagatose that was previously on the market from the lactose-based method. Also, that the lactose-based method had residual amounts of protein, which we have been advised actually cause an allergenetic response in some consumers, I mean. And our tagatose contains no protein. So we have a very, very pure product. It's pretty standard purification, crystallization methodologies. So there's nothing esoteric in the way that we make the final product. It's something that can be consistently done.
Great. Any other questions from the attendees? Give a few seconds to
Sure.
Type in any more questions. Ed, I guess while we're waiting for any final questions, can you talk a little bit about your international scope and kind of where you see the biggest markets? Obviously, the chronic disease is huge here. It's huge in some other countries. How do you make sense of the international market for sugar substitutes?
Yeah. And by the way, my email is on the screen here. Anybody that has questions they would prefer to do offline, they're welcome to email me. So international, actually, as you know, Tom, from our Series A round, I don't want to mention the names, but from our Series A round, we had two strategic investors that were from overseas, one from Japan, a very well-established food company in Japan that we're very, very pleased to have as an investor and look forward to having them as a customer and a collaborator as well. And then another one from Thailand that is a excellent partner too. And also involved in the food industry. So there's, that's one indication of international interest. We have ongoing discussions with potential distribution partners in pretty much everywhere in the world. Probably the next big market will be EU for tagatose and allulose. Allulose is unfortunately not yet approved in Europe, but tagatose is, and we will have our tagatose approved there as well. There's sugar is consumed everywhere. Some of the places where sugar is consumed a lot are, let's say, developing economies, and because of our ability to get a low price point, frankly, trending to high fructose corn syrup levels, we think that even some of those developing economies will be consumers of our tagatose and allulose. So we have a global outlook. We're focusing on the United States at first, but we do have a global outlook, and we think diabetes and other issues that are often associated with excess consumption of sugar are not limited to North America. Tom, I don't know if you're on mute, but if you're asking me a question, I don't hear it. Tom, I see there's a question in chat that says, is Bonumose aiming to eventually replace traditional sugar or complement it? Both. We think we'll replace some, but we think there will also be some opportunities for sugar and tagatose and allulose to be used together in blends. We definitely see that happening.
It looks like we may have lost Tom.
Yeah, I thought we may have. Let's see, there's a question I see in the box, another one. Do allulose and tagatose have the same high time temperature control thresholds for food safety as sugar? I'm not sure what that question means, but I'll answer this question. It may not be the question that's being asked, but we have submitted a full GROS notice, generally recognized as safe notice, to the FDA regarding our process. So our process is being fully vetted. It's not just a self-affirmed GROS. Our process is fully reviewed by the FDA, which includes a whole host of data regarding the safety of our process. So Eva, I don't know if there are any other questions that you can see on your end.
Did we get the ones in the chat? Is Bonumose aiming for eventually replacing traditional sugar or to complement it?
I did address that, and the short answer is both, because we will. I think there'll be some replacement, but in some cases, it'll be a blend. I think a really good application is ice cream, for example. Our distribution partner has a great formula for using sugar and sugar and tagatose to produce ice cream. So not 100% of the sweetness is coming from tagatose. Some of it's coming from sugar. And so there'll be a lot of blends like that.
Great. Well, a question we like to end with is, what can the audience do to help you out with where you're at, and how can they find you?
So they can find us online, bonumose.com. I won't spell it out, but it's on the presentation. And listen, I'm happy to answer any questions. If somebody wants to email me, I'd get back to them. I try to get back pretty quickly. I've not been as good about getting back to people as I would like to be, but happy to talk to anybody that's interested in what we're doing.
Thanks, Ed. Thanks for joining us today, and congratulations on your progress to date. And we'd also like to thank the audience for your active participation. And to let you all know, we host these calls every week at 3 p.m. Central. You can register for AgriFood Conversations webinar series by going to agrifoodconversations.com. And we'll be sticking with this sugar reduction theme for the month of November.
Thank you, Eva.
Thanks.
Bye-bye.